Yeah, so today I'm going to talk a little bit about Moonbeam. How does it work? Under the hood, but without going into too much technical details, and like, what do we offer that it's not possible in other EVM chains because it's a very competitive landscape, right? So, first of all, let's briefly talk Moonbeam and why it's different from other EVM chains out there. So Moonbeam is an Ethereum compatible smart contract platform on Polkadot. A lot of people don't really know, but in Polkadot you cannot build applications. People know Polkadot, they know the brand, but when you tell them, but do you know that you cannot build anything on Polkadot itself, or an application? And they're like, oh, I didn't know that. So basically, on Polkadot, if you're going to build something, an application, you usually go to Parachain, which is a parallel blockchain, basically, like Moonbeam, if you want to build a smart contract based application. And so, as any EVM compatible blockchain out there, the core layer of any EVM compatible blockchain is an EVM. An EVM is a state transition machine in which you say, okay, I have a list of transactions that usually involve smart contracts, and then the machine will sort of run through these transactions and will calculate a new state. And so that's how any EVM compatible blockchain works high level. But so this is the base layer, right? And we have like added layers that makes us be more flexible, offer things that are not possible in other EVM compatible blockchains. And the first one is that we're built with Substrate or the Polkadot SDK, and this allows us to basically connect to Polkadot very easy. Like it's a native way to do it. It allows us to be very modular or on how Moonbeam is built, and so we can offer things like I said before that are not really like EVM standards, among any like a bunch of other things. We have really fast finality, and this is something that people don't really understand when they're building L2s. Is that even though it's like a hot word, L2 finality is really bad. It's like 15 minutes to 20 minutes, and depending on the application, you need really fast finality. On Moonbeam, because we're part of the Polkadot ecosystem, we get finalities around 12, 20 seconds. Block times are going to be soon to be 6 seconds. So it's really fast, and you have really good guarantees that your transaction is finalized in a really fast in a short time. We have full Web3 RPC support. This is why we're Ethereum compatible at client level as well, and that's why you have MetaMask, you have Hardhat, Foundry, all the tools that Ethereum developers love and know. They work out of the box on Moonbeam is because we speak their language basically, and we're going to talk about how this works in a bit lower level. And last but not least, that's something very unique about Moonbeam is that we have a single account system. So normally Polkadot blockchains use an account system that is not, let's say, Ethereum standard. And so we've modified this at a core layer so that we work with Ethereum accounts. And there's no you don't have your sort of Polkadot based accounts and then, Ethereum based accounts. You have a single account system, which is a lot easier for Ethereum developers because that's what they're used to using, right? But let's talk a little bit about like how we bring Ethereum compatibility to Substrate. And first, let's understand what Ethereum compatibility is, right? When you have a user, a tool, someone in blockchain interacting with Ethereum, the way that this works at a very high level is to what is known the Ethereum JSON RPC. And so how this works is that, let's say I am a user, I have a wallet, MetaMask, and I connect to Ethereum mainnet. So my wallet is going to do a call to the Ethereum node or the node provider that is going to be, hey, what's my balance? Or hey, I have this transaction that is signed. Can you please send it to the network? Or hey, I want to know the ERC20 token balance of Albert token, the greatest token in the world. And then basically that call, the node will get it, will understand it, will process it, will fetch the information from whatever it needs to fetch it, and will provide a response with Alberto has this balance, or hey, there you go, I've sent your transaction, or hey, you have this X amount of balance of the Albert token, right? So in theory, right, if you put whatever blockchain here that is not Ethereum, but it's able to understand this flow, you are now basically unlocking a new set of tools that you can work with your blockchain. So if you want to learn more about the Ethereum JSON RPC, this is the link if you want to learn more, and you have all the basically methods that you can put in this call and the type of responses. And so let me run you through a concrete example. This is MetaMask. This is connected to the Ethereum network testnet called Sepolia. And so basically underneath what MetaMask is doing is using this methodology called ETH_get_balance with the account that I have. And basically the network responds like this, which is a number that doesn't mean anything for you guys, but if you transform it from hex to decimal numbers, you can see that it's the balance of that account. Like I said, this is on Sepolia, and so this is how the Ethereum JSON RPC works at a bit lower level, let's say. So when I understood this, I come from a non-technical background. when I understood this, I was like, I mean, this is pretty great because it means that it doesn't really matter what is in the other side of that JSON RPC call. If it's understood, if that thing understands it and responds whatever it's expected as a response, then you're kind of Ethereum compatible at a client level. So this is what Moonbeam is doing, right? Basically at a client level, we have a call. Like I said, it doesn't really matter what call it is. And then Moonbeam has in its runtime, it has a client-side thing that it's called Frontier. Frontier is many things, but for the point of this conversation, let's just say, I like to say like it's a dictionary that is able to convert Ethereum language or Ethereum calls into something that we understand in Moonbeam, and then basically we can provide the response that the tool expects, right? So if MetaMask connects to Moonbeam, it's going to say, hey, can you get me the balance of this account? Frontier is like, okay, wait, the balance and Ethereum means that I have to go here in Substrate, I have to fetch this kind of piece of code, and I have to respond it, and then Frontier say, okay, thank you, I'll provide it now in this format so that the tool understands it. And so basically what we like to say is that on Moonbeam, you don't have to think about it. You just have to say, okay, you can use MetaMask, you can use Hardhat, you can use Foundry for Ether.js or whatever, because we abstract all that complexity for you, as well as other EVM chains in Polkadot. It's not unique to us because Frontier is an open source software that was developed by Parity in conjunction with Moonbeam, and anyone can use it. So I did say, and probably I missed to say it, but we offer a little bit more than just like a typical EVM. And how this works is basically Moonbeam has like an Ethereum side of things. Like I said, for example, you can connect MetaMask, Ledger, and then we have this like the thing that I just mentioned with the Ethereum JSON RPC. But we also have the substrate interface, which is a bit more complex because you have a lot of things that are not EVM standard, like governance, you have interoperability, you have staking, things that are not really smart contract based, they're runtime based, they're not EVM bytecode. And so if you see the difference between these two images, right? These kind of interface is not known to these Ethereum tools. So you might ask yourself, how can an Ethereum developer access governance or access staking? Because that's not smart contracts, like I said. And so the way that we do this is something called precompiles, which is an access layer from the Ethereum side. It's an access layer to the substrate side. And so Ethereum developers can now build smart contracts that can access these features. And so it expands the baseline Ethereum offering or EVM offering with a set of extra tools that are not only like staking and governance. We actually provide a lot more, and I'm going to show you a couple examples here. And so, the fun way I like to present precompiles is that as a developer, you don't have to know Rust or Substrate. You don't have to know the Polkadot.js SDK. You don't have to know Polkadot Substrate terminology. You can just focus on the functionality of the precompile, the precompile address and a function to call, basically. So as a Solidity developer, you can have a lot of extra functionality that is pretty advanced underneath without having to understand all the terminologies, technicalities. It just works like in a smart contract, and that's really powerful. And that's something unique to Moonbeam or Substrate or Polkadot SDK-based blockchains because they're so modular that you can do these kind of things. So I'm going to show you a couple of examples which are pretty unique, and these are unique to Moonbeam because I think we are the only teams that actually provide this in the ecosystem. And the first one is called the batch precompile. So a thing that you cannot do on Ethereum is that you cannot batch calls and then have one signature from an EOA account, an externally owned address, to sign that call, that call is going to do multiple things. You can do that via smart contract wallets, but it's not the same. It's not a person signing on a Ledger device or whatever. You're doing a smart contract wallet. How the batch precompile works is that you're able to grab a bunch of calls, right, and have a user through an application sign one single transaction, and that's going to underneath what's going to happen is that Moonbeam is going to process that transaction. It's going to do multiple EVM calls from a single signature. And the great thing about it is that this creates so much better user experience. And the example that I like to give is basically an NFT a marketplace, right? Or even a game, right? Imagine you're playing a game in which you are a user where you go to a store in the game and you want to buy like a sword, a piece of armor, helmet, whatever, shield. And the typical Web3 flow, each of these things will be one single transaction. Like, I want to buy the helmet. Okay, sign this. I want to buy the sword. Okay, sign this. And that just provides really bad user experience. With the batch, you can just say like a shopping cart experience. I want to add my helmet. I want to add my sword, my helmet, whatever. I want to check out. You pay, and that's it. One single transaction. A lot more closer to like what a Web2 experience is kind of like, which is really good from a user experience perspective. It is really intuitive and super simple to use the batch precompile. Everything is documented. I think the links are in the presentation, and I'm not going to go to the details of like how you do it, but it's extremely simple. You can batch everything atomically, meaning that if one of the subcalls fails, everything fails. You can say, I want to batch until some of the calls fail, and then everything before it, it's okay, and everything after it, it's not executed. Or you can say, I want to batch everything, and if one of them fails, I don't really care. So you have a lot of flexibility. And this batch precompile is widely used in Moonbeam. And I think if you click here, I'm not going to click on it, but if you click here, you'll see all the transactions that are being handled by the precompile. The other really cool precompile that we offer provides gasless transactions to any Moonbeam smart contract without having them to change the contract logic, which is how it's normally implemented on Ethereum. So let's say I have a game, I want to use gasless transactions. These are transactions in which the user doesn't pay a fee. There's someone else that pays it for him. On Ethereum, you need to have the game change the smart contract logic to support this. And that's really bad because it introduces security concerns, and you need to upgrade the contract, and it's just a lot of things. With Moonbeam, you can use a precompile that allows you any call to be gasless, no matter which call. And like we actually, one little fun experiment that we did with this game called Damn Pirate Society is that we grabbed their game without them knowing it. We implemented an example in which they would pay for a voyage of the pirates in the native token of the protocol called Glimmer. But they had a token called doublons. That's like a pirate token, right? So imagine you playing a pirates game and you have to pay the voyage in something called Glimmer, not doublons, which is like the in-game token. So ideally, you could create the flow in which you can actually it was repairing the ship, yeah. So you could create a flow in which you can repair the ship, which is it's an on-chain transaction with doublons, and then someone else would just pay the transaction in Glimmer, and that would just be better for like end user experience. So like I said, no smart contract modification, dApps can submit user transactions, and overall you improve the user experience. We have one game that did a solution around this, and they were submitting a bunch of transactions through it, and it works really well. It's just better user experience overall. I'm not going to go through this just because of time, but these are some examples of like the precompile, how they work, how you can use them. It's pretty, like I said, it's pretty intuitive. The batch precompile, you can learn how to use it in 3 minutes. The call permit precompile is a little bit more complicated because you need to understand signatures, you need to understand what a deadline is, and so on. But we have everything really well documented, and it's not that hard, to be honest, if you're already developing on Ethereum. So yeah, I'm not gonna run through this, but basically the idea is that Moonbeam acts as sort of like a hub for interoperability in and out of Polkadot. We saw that example with Manta that they launched their L2, and they also had their parachain. So Moonbeam was a hub for going in and out. We also we're collaborating with a lot of teams on like sort of how they can access out of the Polkadot ecosystem and into the Polkadot ecosystem. And Moonbeam plays a key role in that sort of like position, at least for now, because we have also Bridge Hub, so we'll see what happens. But yeah, Moonbeam is really well connected to the entire blockchain ecosystem as a whole. But yeah, I don't want to go into too much detail over here. But yeah, thanks a lot. You can scan the QR code for the slides. If you're interested on Moonbeam, you can check us out in Twitter, Telegram, Discord, or check our website. If you want to talk to me directly, you have my Telegram and Twitter. I'm always open for any questions. I love to talk about all this stuff. So yeah, thanks a lot.